The mind map on query profiling, analyzing resource usage for queries, provides an organized overview of the concept, breaking it down into several key aspects: purpose, key metrics, tools and techniques, common issues detected, and best practices. Here's a detailed explanation of each section. 1. Purpose. Optimize query performance. The main objective of query profiling is to ensure that database queries execute as efficiently as possible. It aims to reduce query execution times, minimize resource consumption, and ultimately enhance the performance of applications that rely on the database. Identify resource bottlenecks. By profiling queries, developers and database administrators can pinpoint specific resource constraints like memory, CPU, or disk I/O that slow down query execution or negatively impact overall system performance. Key metrics. Query profiling involves monitoring various metrics that indicate how a query affects the system. Execution time measures the time taken for a query to complete. Long execution times can indicate poorly optimized queries or inefficient data retrieval methods. Memory usage monitors the amount of memory consumed during query execution. High memory consumption may suggest large data sets being processed, suboptimal joins, or poor indexing strategies. CPU consumption tracks the percentage of CPU resources used. High CPU usage can result from complex calculations, sorting, or the processing of large volumes of data. Disk I/O operations analyzes the frequency and volume of disk read-write operations. Excessive disk I/O can indicate issues such as full table scans, lack of indexing, or frequent access to large datasets. Tools and techniques. Various tools and techniques can be used to perform query profiling, helping to diagnose and optimize queries. Database built-in profiling tools. Many databases, such as MySQL, PostgreSQL, and SQL Server, come with built-in profiling tools or extensions that allow users to analyze query performance. Explain commands. Most relational databases offer an explain command that provides details on how the database executes a query. It shows the query execution plan, which helps in understanding how data is accessed. Query execution plans. Execution plans give a visual or textual representation of the steps taken by the database engine to execute a query. They highlight potential inefficiencies, such as full table scans or suboptimal index usage. Now 4. Common issues detected. Query profiling can help detect several performance issues, including slow-running queries. Queries that take too long to execute can degrade system performance. Profiling helps identify the reasons behind slow execution, such as poor indexing or inefficient joins. High memory or CPU consumption. When queries consume too much memory or CPU resources, it may indicate that large datasets are being processed unnecessarily or that the query could be optimized further. Inefficient use of indexes. Profiling can reveal if queries are not taking advantage of indexes, leading to slower performance. It helps to identify cases where adding or modifying indexes could improve query speed. 5. Best practices. To optimize queries and maintain good system performance, the following best practices are recommended. Regularly monitor performance. Continuous monitoring helps catch performance issues early. It allows for proactive optimization before issues become critical. Optimize slow queries. Profiling helps to focus on the queries that are the most resource-intensive, ensuring that efforts are directed towards those with the greatest impact on performance. Use appropriate indexing. Properly indexed tables can significantly speed up query execution by reducing the amount of data the database needs to scan. Avoid resource-heavy operations. Operations like full table scans, sorting large datasets in memory, or complex calculations